In this video, we're going to look at an interesting exponential type function. If this was just an e to the x or e to the negative x, that's kind of a classic exponential growth decay shape, but when we start to get the squared in the mix, you can get some really interesting things happening. So I need to think about if this function is continuous and what my interval looks like. My interval is definitely open, so I'll need to investigate both ends. And when I look at e to a power, that's always continuous. So I don't have any discontinuity. So it'll just be the two limits that I'm looking for to figure out whether or not I even have a max or a min. So I'll take the limit as x goes to negative infinity of k of x, and the limit as x goes to positive infinity of k of x. And then I will compare that to what's happening at my critical values. So let's find k prime of x to get critical values. The 4 is going to drop out. The negative in front of the e is just a constant multiple -1, so it sits there. E to a power is its own derivative, but the chain rule says that we have to spit out the derivative of negative x minus 2 squared. So we'll multiply by negative, and then the 2 drops down, you get x minus 2 to the first power, and then technically there's one more chain, so that dealt with the constant multiple, that dealt with the power. We need to multiply by the derivative of x minus 2, but that is just 1, so we're in pretty good shape. Before I make any mistakes with it, I'm going to cross those out, say this ends up being positive. So I get a 2e to the negative x minus 2 squared times x minus 2. I would not multiply that out. Factored form is fantastic when you're planning on setting something equal to 0, and we basically got it for free here. Okay, so once again, the question is it ever undefined? And the answer is the same as before, no. E to a power is always defined, so it's really just the 0 question. And I can split this up into two factors. First would be when is 2e to the negative x minus 2 squared equal to 0? And second would be when is x minus 2 equal to 0? So that second question is the easy one. X equals 2 is definitely a critical value. That first one is impossible, but if you don't notice it immediately, I would say try to remind yourself that e to a power is never 0. It's also never negative. But you could start through the algebra. You could divide both sides by 2. And then you'd get e to the stuff equals 0. And then if you're continuing algebraically, you'd take the natural log of both sides to bring down that negative x minus 2 squared. And you'd get natural log of 0. And if you don't remember that e to a power is always going to be positive, maybe that one will jump out at you. You can't take the log of 0, so we get stuck at some point here. So one and only one critical value at x equals 2. That's kind of reminiscent of the last problem. This means that my list of y values to compare is 2 places where we might find out that there is no max or min, and 1 place where we could find either a max or a min, but not both. So I need to plug in 2, and I get 4 minus e to the 0. So e to the 0 is 1, which means it's really just 3. So I get this y value of 3. It could be a global max, it could be a global min, it could be neither. To figure that out, I'm going to have to do some really careful limit thinking. And again, this doesn't mean you have to do a lot of algebra. If you think algebra will help, use it, but often in these we don't need to. It might help a little to think about this as 4 minus 1 over e to the x minus 2 squared. That negative power really means we're thinking about it being in the denominator. So now if I'm plugging in really big negative numbers, it's 4 minus 1 over e. So negative number, big negative number minus 2, basically still our big negative number. So let's say we're plugging in like negative 1,000,000. So we're ending up with roughly negative 1,000,000 squared, which means we get a really, really big positive number. And then when we raise e to a really big power, we get an insanely huge positive number, which means this fraction is going to 0. So as x goes to a negative infinity, our y is approaching 4. When we let x go to positive infinity, Again, the -2, the -2 doesn't really affect that. So if we're plugging in 1 billion, we basically have 1 over e to the billion squared, which is 1 over e to a huge positive number. E to a huge positive number is a massive, massive, massive positive number. So again, this fraction is going to 0. So on both sides, our y values are approaching 4. So as I try and visualize this, I'm thinking, okay, I think I have horizontal asymptote at y equals 4. And I'm approaching that on both sides. Since it's a 4 minus, I think I'm probably approaching from below. I'm going to get numbers slightly smaller than 4. And then at x equals 2, I drop down to a y value of 3, and that's my only critical value. So I think that I'm probably just getting this little, that doesn't look very symmetric, but this little dip down below. So I do have a global minimum of 3 at x equals 2 and no global maximum.